This video is on 4.2, more application examples. So this is for linear functions, and really you want to focus on the concepts, the interpretation, the function vocabulary, and putting things in everyday language based on the data that we look at. So we have number one here, a booth at a county fair only sells cotton candy. The following graph shows the supply S, how much cotton candy the booth is willing to make, and demand D, how much customers are willing to buy. For bags of cotton candy as a function of the price P that the booth decides to charge per bag. So this graph, whenever you make a graph, you want to have a title, if possible, supply and demand for cotton candy. We would label our y-axis, our vertical axis, number of bags of cotton candy, and P is our price. So the vertical axis, we have two different functions represented. We're going to say Y is D of P, the demand, and we also have Y axis being supply of P, S of P. So what is the supply if the booth charges $2? So if my price is $2, I can look down here at 2 and then travel up, and I'm going to find this point where it hits. So that's for demand, actually. So let's get rid of that one. That will answer the second part. First one, we want to look at the supply. So our supply line is right here. I'm just going to make that a different color just to so we can really differentiate that. So this is our supply, is the pink line here, and then I will make the other one, the demand, this blue, just so you can see when I'm putting the colors up. So if I have $2 and I go up to this pink line is the supply, then I look to the left at my y-axis and I want to see about how much that is. So at $2 I would have the point right here, and so that would be 2 comma let's see, 2 4 6 800 1,000, so that would be 600. Okay, so if it's asking just about the supply, I would just reference the supply only and say the supply is 600 bags at that $2. Now, what is the demand? We're going to take that same $2, but this time we're going to keep traveling on up till we hit the demand line and look to the left and see that our Y value is 3,000. So the demand is 3,000 bags. So that is pretty high, but the supply can't, it's not keeping up with that, obviously. So you would write down, you can write the point 2 comma 3,000 just to track it there, and then you would write the demand is 3,000 bags. So quite a difference there. So how can we get the optimal price to make things work out? Because we don't want, if we make so many at a low price, we're not going to hit a sweet spot with our what we call equilibrium, is actually where they cross. So part B says, what happens to supply if the price is increased by $1? So let me get rid of this green here and the yellow. If I increase by $1, then I'm going to travel over here to, let's see, 3, and then I hit okay, so I'm gonna be at $3 and I hit the supply line and I am at now 1,600. So compared to my 600 earlier, my supply will increase by 1,000 bags. Okay, so I'm now having, if I have 3,1,600, that meant for an increase of $1, the supply increased by 1,000 bags. Okay, it was 1,600 total, but the increase from our 600 earlier was 1,000. Now we're going to look at what is our equilibrium price. So we are going to look where they cross. That means they're equal, that supply equals demand. So this is when we want to find when S of P equals D of P, or vice versa. So I can look at the graph and I look down and I'm going to get, let's see, this is like 2, 4, 6, 8, 10. That's about at a 3, so I'd say $3.30. So the equilibrium price is $3.30. At what prices will there be a surplus? So we have to look at when we're over that equilibrium, when our supply is more than our demand. So that would be this piece of the graph here. Let me, I'll just use the laser pointer here. So this line segment for supply, that is a surplus. It's extra, more than we actually need. So we're going to say for which X values, or in this case P, would that be true? It would be anywhere from that equilibrium price on up. Okay, I mean, it does kind of cap out for our domain, but we can just write it, anything over $3.30 will have a surplus. So just so you can put that in a sentence, we have a surplus when our price is greater than $3.30 or something to that effect. Letter E, at the equilibrium price, what is the booth's revenue? So how much money do they take in when we have the equilibrium price happening? So for this one, we have to just do a little bit of math. We know that our equilibrium price is going to be $3.30. We know that given that price, our demand and our supply are both the same, and I'm just going to estimate over here, I don't know if it's exactly, but pretty close to 2,000 bags. So I'm going to put units in here just so we can track what we're doing. So we have at $3.30, whoops, I should say 2,000 bags. So 2K bags or 2,000. But what is the revenue? Revenue means how much money did I take in? So it would be the price times the number of bags. So we actually have to multiply those two things together. So go ahead and do that. And we would have 3.3 times the 2,000 for the number of bags is going to equal $6,600 in revenue. That's how much we earned. Okay. Or how much we took in. Say profit is really what we earned. So if the booth rental costs $700 and ingredients cost 30 cents per bag of cotton candy, find the booth's profit at equilibrium price. So we know we took in, so that's why I wanted to clarify that too. The 6,600 is what we took in. That's our revenue, but we have to subtract our costs off. So profit, P, is going to be revenue minus costs. So we gotta kind of just figure that out. So we have a $700 booth rental and then 30 cents per bag. So we can make an equation here. We could have this equation here, C of y equals 700 plus 0.30y, which is 0.3y. I'm putting y in there because y over here is the number of bags of cotton candy, and that's what we're referencing. So kind of we're rolling that into the cost function. So if we said before that we had 2,000 bags at our equilibrium price, then we are going to need to put y equals 2,000 in there and crunch the numbers. So let's go ahead and do that. Okay, so we get that the cost is going to be $1,300 for the cost at the 2,000 bags. I'm just going to push this up a little bit here. So then we have our profit, remember, is going to be the revenue that we took in, the 6,600. I guess we could call this P of Y if we want. And then minus the $1,300 for the costs. And I'm going to get a total of $5,300 in profit. Okay, so that's the answer to part F. So here we have find the slope of D and explain its meaning using everyday language. That's part G. So we have to look at D up here, back on the graph. And so this is descending left to right, it's decreasing. So it's a negative slope. And we could just kind of figure that out based on the grid. We could pick a couple points on there and actually calculate it out. But let's see if we can just sort of tell. So I just picked a couple points that really fall clearly on corners to make it easy. This is our down 800, so that's minus 800 units. And this is across 1 unit. So my slope would be, or average rate of change, or M, because it's linear, we can use that. Negative 800 over 1, which is negative 800. So this will tell us that when the price goes up $1, so it's kind of, you almost word it backwards than how you think of it, maybe as a regular slope. You know, we're saying here down 800 for every dollar increase, you could say that. Or you could say when we increase the price by $1, the demand will drop by 800 bags, is a pretty typical way to say it. But sometimes it makes a little more sense because you tend to say the numerator part first. But whatever works for you, I'll write that down for you. Okay, so I just wrote down here the slope is negative 800. This tells us that when we increase the price by $1, the demand will drop by 800 bags. So we want to be careful about, increasing the price too much. Again, there's that sweet spot that people are going to say, forget it, I don't even want that. So it's not worth it. So that is done a lot in marketing. They need to collect data and see how much people are willing to pay for certain items. And then they develop a model. And we're going to do that next after the test. So next week we'll look at developing models based on real data. So H is find an equation for D of P. So let's see if we can figure that one out. Take a look and see if we can set that up. We know the slope, and what other things do you know about that function by looking at the graph? Okay, so if we look at the vertical intercept here, we have y equals D of P, so that is going to be at, that's 42, 44, 46. Let me just put that down a little so you can see the top. So 4,600 is our y-intercept, so we can jot that down. So we have 0, 4,600 is our y-intercept. We know our slope equals negative 800. So we can just write that in terms of D of P. D of P equals 4,600 minus 800P. So we're relating that back now to price, where before, when we were figuring out profit and revenue and cost, we had to use the Y value. Letter I is determine a reasonable domain for range and range for D of P. So if you think about it, what is the lowest price that you could have? And you may think, well, 0, that would be free. Do we want to include that or not? That's up to you. I would say, well, we could give away the, so I think that's reasonable, 0. And then we go all the way over, if we look back at the graph, and it hits 0 on the x-axis, that demand goes all the way down to hit the x-axis at about $5.80. Okay, so that's as far, like we couldn't have a price of $6. We have no bags left to sell, right? It's just, or the demand, I guess, is actually the demand. Nobody wants to buy it. Okay, so there's no bags being sold. And then range, so Y value. So again, we can start at the 0. So there's no demand. That matches up with our 5.8. And then we go all the way as high. Got a little whacked up there. We get all the way up to that y-intercept when we have a price of 0 and we're giving them away. So that would be the 4,600. All right, and that's it for this one problem. There's a few more that I'll do with you. I'll probably just make separate videos for all of these. So just look for a continuation onto your worksheet. You'll have a couple more.